All right, just a little example of proof. So last lesson we were looking at the trig identities, with some of the basic proofs. Now we're looking at using these identities more and potentially some harder proofs. But remember the process of a proof that we've been doing. We've been saying left-hand side equals, and then we've been manipulating the left-hand side, then all of a sudden it will equal the right-hand side. So that's what I want you to make sure you are working on today. Have that structure. Okay, so that structure there should be on all of our processes. Right, so let's have a look at this one. So the left-hand side. Now, if I look at the left-hand side, I've got a sine squared and I've got a cos squared. And on the right-hand side, all I've got is sine squared. So to me, that makes me think, oh, I've got to use this one here and rearrange that so we've got cos squared theta is actually 1 minus the sine squared theta. That way I'm going to get rid of the cos squared and I'm only going to get sine squared. So let's rewrite that as sine x minus 3 of cos squared. So that's 1 minus sine squared x. And hopefully now you can see, well, yeah, okay, I know where I'm going. So I'm going to be expanding that bracket. Sine squared x minus 3 plus 3 sine squared x. Oh, I've got 4 lots of sine squared x minus 3, which is my right hand side. That's question 1 of exercise 6.02, page 95. So, have a crack at the other ones. Here's question 5 of that same exercise. So, cosec minus sine over cosec. Now, I'm not sure what's going to happen here, but let's have a look. So, starting off with the left-hand side. Now, I've got cos on the right-hand side. So, what I've been trying to do, and what I told you guys last time, is to convert cosecs and secs and cots into sines and cosines. So I'm going to turn cosec into 1 over sine. So, actually before that, I'm going to break that fraction up. Cosec x minus sine x over cosec x over cosec x. I'm just splitting up a fraction there. So you guys should be aware that, 1/2, let's go with 1 over 21 plus 3 over 21, that's 4 over 21. You should be aware of x over 3 plus y over 3. When I've got the same denominator, I can just add those fractions together. What we're doing here is actually going, I'm breaking that fraction up, splitting it over the same denominator. Hopefully you can understand what I've done there. So now I'm going to do, what I'm going to do is I'm going to say cosec x over cosec x. Well, that's just 1. That's minus sine x over 1 minus, sine x over 1 over sine x. Now, when I've got a fraction of something divided by a fraction, that's the same as multiplying by the reciprocal. Which is 1 minus sine squared x. And again, from over here, rearranging that trig identity, 1 minus sine squared is cos squared. So that is cos squared x. And that is my right-hand side. Doesn't matter if you put it there or you put it there. It's the idea about the left-hand side equals the right-hand side. Left-hand side equals, it's equal to the right-hand side. You're only manipulating the left-hand side or the right-hand side to get that final answer. Hope that's enough for you to have a crack at 6.02. If you have issues, talk to the people around you. And if you have issues, contact me on Teams and I'll give you a bit of a hand.